Hi everyone. Hi everyone, welcome, and we are going to talk about solving quadratics. Surprise, surprise, like we've been talking about for it feels like a year, but not really. So we're talking specifically about completing the square and factoring as methods to solve quadratic equations. So solving for x, finding those roots, solutions, x-intercepts, and zeros, right? So they've got four names, but we're really just talking about turn that y into a zero and figure out what x is equal to. All right, so you have a warm-up, and let's get to that first. So we've got two sequences, and Ravon creates the following table of values to compare these two sequences. So in red, I'm going to kind of focus on this sequence A. And in black, I will focus on this sequence B. Okay, so I kind of like to write them separately. So I'm going to write the term number, right? That's really my x values. So I'm going to write that term number 1, 2, 3, 4, and then sequence A below it, just to give myself some more space. Okay. So these are my inputs, and these are my outputs, or y's. Okay. So I look at the y values to see kind of what is happening. And I see that it goes up by plus 3. 2 plus 3 is 5. 5 plus 5. Oh, so it's not linear, right? It's not going up by the same amount. Okay. And now plus 7. Okay, so it's not linear. Okay, so now, well, let me see what the second difference is. So 3 plus 5 is, 3 plus 2 is 5. And 5 plus, here I've got the constant second difference. Do you guys remember what type of function that is? Okay, so it is quadratic. So there's a perfect square somewhere in here. Okay. All right, so we've got a perfect square. Interesting. So I'm just going to erase a little bit of this. And so I know it's got a perfect square. I know that this x value, right? These x values right here, right? Like if I did 1 squared here and 2 squared here, right? I'm just taking whatever the x value is and squaring it. 3 squared and 4 squared. So here, 1 squared is 1. And then I can add 1 to that to give me 2. 2 squared is 4 plus 1 is 5. 3 squared, 9. Oh, okay. Plus 1. And 4 squared is 16 plus 1. Awesome, right? I wonder what would happen if I did that here. 0. So 0 squared, and then I'm getting this constant plus 1, right, would go there. And that would keep with my sequence. Remember I did like plus 3 plus 5. 1 plus 1 gives me that 2. So you could go back and play around with that if you want. So my first equation is whatever the x value is squared plus 1. All right, cool. So now let me do sequence B. So I've got 1, 2, 3, 4 for my term numbers for those x values. And then for sequence B, or my y values, 20, 40, 60, 80. Okay, so plus 20, plus 20, plus 20. Okay. Oh, so my first difference is constant, right? So that would be linear. That would be a linear function. Now, it's been so long. How do I even do linear functions, right? Okay, so I know that finding where the 0 is kind of important. So if I go back, then this would have to be 0 also, right? Because 0 plus that constant of 20, right, would be there. So here I've got y equals 20x plus 0, right? And I don't have to put plus 0. So 20 times 1, oops. Let me get my pen back. All right. So 20 times 1 is 20. 20 times 2 is 40. 20 times whatever the x value is gives me the y value. All right. So a system of equations just means more than one. So these are a system. So if I were to graph them, right, my linear function would be, x is 1, I mean, you know. So it would go through, oops, it should go through 0, 0. So sloppy 1, and then here, this plus 1, remember that shifts it up 1. So if my regular parent function quadratic goes through the origin, this would move up like 1 spot, right? So right there would be where y equals 1, right? That just moves it up 1 space. Cool. All right, enough on that. All right, so here's the real meat of it. We've done factoring. Remember, factoring, we have GCF is a type of factoring, trinomials, and then we have difference of two squares, right? Like x squared minus 16, right? So two perfect squares with a minus in between them. And a type of trinomial, which is a perfect square trinomial, right? Where it has a perfect square to start and to finish, similar to dots, right? To difference of two squares, except the last term is always a positive. And then, oops, the first term is also a perfect square. Sorry about that. And then whatever the square root of 16 is, so 4 squared, right? Then I do 4 plus 4, so I could have 8x, or I could have a minus 8x, right? So when I combine those perfect square terms, it gives me what's in the middle. So those are my 4 types of factoring. So I can do any of those 4 types. And the thing that makes this different than the complete the square method is I always have to have a 0 here. I will be using the 0 product property. So on the worksheet, if they ask you, hey, what's one of the differences between these two types of solving quadratics? One of the differences is that you're using the 0 product property after you factor. Has to be 0 here. Okay. Whereas in completing the square, it actually does not. All right, so let's factor this. I'm going to take my area method that I love so much. First term goes in the first box. Last term goes in the last box. I'm just checking to see, is that a perfect square? Maybe it's a perfect square trinomial. And no, it's close, 25, but not 24. All right, and then these two middle ones have got to either add or subtract to 11x, right? That middle term. So that's really where I'm going to play around with the factors. Do they combine to positive 11x? All right, so here I've got x times x. And then 24, I've got 1 times 24, 2 times 12, 3 times 8, yes, 4 times 6, and the next one would be 6. And because of that repeat, if I go in order, like 1, 2, 3, if I go in order, as soon as I see a repeat, I know I found all of the factor pairs. All right, so which one of these guys do you think, right? Because I've got a positive 24 here, so I've got to have the same signs, right? They'd either both have to be pluses or both have to be minuses, right? And it looks like both would have to be pluses to add to give me a positive 11x. So can you spot the pair that would add to give you 11x? All right, so here it is. 3 plus 8 equals 11. So I'm going to put 3 and 8. So now let me just give it a check. X times x is x squared. X times 3 is 3x. 8 times x is 8x. And 8 times 3 is 24. All right, so it looks pretty good. So my factors, right? And remember, if I don't have a sign there, that automatically assumes positive. Okay, so these are my factors, the entire length. So I can rewrite my standard form in factored form as x plus 3 times x plus 8 equals 0. All right, now you know I gotta erase because I always have to erase. Yeah, I'll erase this too. And good job for those of you keeping up with your note tracker. You are rock stars. Okay, so I'm just gonna rewrite it up here and we'll continue along. Zero product property can only be used if I've got a 0. So it's used when I'm factoring and it's equal to 0. If I have any other number but 0 here, it does not work. So zero product property says I can set any of my factors, once it's in factored form, equal to 0. So I put x plus 3 equals 0 and x plus 8 equals 0. All right, so here are my roots. And I've solved algebraically. Anytime you're adding, subtracting, multiplying, dividing, right, anything except for graphing, you've solved algebraically. So if I were to graph it and check, I've got at -3 and at -8, right? On my x-axis, this is where my parabola would go through. All right, so these should match when you graph. All right, so that is factoring. All of these you need to solve by factoring, right? Everything, I think, all of the odd numbers, factoring, factoring, factoring. Even if you could solve it in the other method, okay? All right, so here, by the opposite side, any of the even numbers, you have to solve by complete the square, even if it's easier to solve by factoring. All right, so completing the square, we should start with at least the x squared and the x term on the same side. That's really where we're getting the complete the square. All right, so first thing I'm going to do, make sure that they're on the same side. Check they are. I don't care so much about the 6. Yeah, it can be wherever it wants to be right now. All right, second thing is if x squared has a number in front of it, we got to divide that number out. So everything gets divided by that a term, right? So that a term, remember ax squared plus bx plus c. Oops, it's supposed to be a 0. If that's a number greater than 1, you divide everything by that number. You could even do it with 1, but it just wouldn't change anything. So these cancel out. I get x squared. And then 8 divided by 2, -4x. 6 divided by 2 is plus 3. And 0 divided by 2 stays 0. Okay. So here I could do factoring. It kind of looks like, right? -3 minus 1 is -4. And if I multiply -3 times -1, I get +3. But I'm not going to do it that way. I'm going to do complete the square because I follow directions. So I take these two guys, and let's actually just get rid of the 3. Let's move that to the other side. All right, so I've got x squared minus 4x equals -3. Now, if you notice, I leave a space here because what I'm trying to do is I'm trying to get this side to be a perfect square trinomial. All right, So I'm going to draw my square, and remember, this has got to be a perfect square. So exactly the same factors on the top as on the side. So I take x squared like I normally do. I put it in the first box. This is already a perfect square because it's x times x. Now this middle, this x term, -4, I split that -4x in half. All right, I want half of it, I want to evenly split it, so half of it goes here and the other half of it goes here. All right, remember, I'm trying to get exactly the same lengths on the top and the bottom. All right, so x times x is x squared. X times -2 gives me -2x. And here, this x times another -2 gives me this -2x. So far inside of the box, right? Let me make it a different color. X squared minus 2x minus another 2x. So far I have x squared, and -2x minus 2x gives me -4x. So I've got these two terms there. Here is what I need to complete the square. Okay, that's the main missing point. So now -2 times -2 gives me a +4. And so I'm going to add that to both sides. What I add to one side, I add to the other side. And the reason I'm doing that is so that I make this side a perfect square trinomial. All right, so that's where I'm actually completing the square. And I think we did this sometime last week, so you can go back through your notes or through past week's video and look at that TOC for a little bit better breakdown of exactly the steps I just went through. All right, so now I'm going to erase because I never have enough room. Okay, and let's just keep going with this. So here I have x minus 2 times x minus 2, right? I'm just writing it in factored form. And on this side, -3 plus 4 is a +1. All right, so I'm just going to rewrite this as x minus 2 squared because it's identical. It's the same exact thing. All right, so equals 1. So let me just rewrite that up here, which is why I erased the other side. And remember, the reason I do that, so two things. The reason I do that is to get the perfect square on one side. And if you notice on the other side, this can be any number, right? I'm just trying to get anything that's not the perfect square on the other side. So it does not have to be 0. That's a major difference between the two methods. All right, so now I'm going to do square root, square root. Don't forget your plus minus. Cancel, cancel. And I have x minus 2 equals a positive and negative, and the square root of 1 is 1. So now let me just add 2 to both sides. And this would give me x equals 2 that I just added, plus 1. And it would give me x equals 2, right, minus 1. So I'm doing plus and a minus 1. So 2 plus 1 is 3. And 2 minus 1 is 1. So on my graph, at 1 and at 3, on my x-axis, you should get the quadratic going through those two x-intercepts. All right, regions connection. You can do this one either through factored, and I hope you can see that you can do a GCF here. So they both have x's, so x is my GCF. So x times x gives me x squared, and x times negative 6 gives me minus 6x. Now, zero product property, x equals 0, right? One factor, and then x minus 6 equals 0. I'm just going to add 6. So my roots are x equals 0 and x equals 6. So I would have this answer 3. You can also do it through complete the square. And you could say x squared minus 6x equals 0. Great, I already have the x squared and the 6x, the x term, on the same side. So I don't have to divide the a value because it's already that invisible 1. I just need to add something to it to make it a perfect square. So x squared goes first, and then minus 6x, if I split it in 2, here I get minus 3x, and here another minus 3x. Remember, negative 3x minus 3x gives me this minus 6x. All right, and I'm going to make that invisible again. So I got the x squared. All right, so I've got both of these terms inside of my area method. Now I've got to figure out what do I need here to actually complete this square. All right, so x times x. Now, x times negative 3 gives me negative 3x, and x times another negative 3 gives me this negative 3x. All right, so now negative 3 times negative 3 gives me a positive 9. That is what I need to complete this square. So I'm going to add 9 to this side, and I'm going to add 9 to my other side. So I've got a perfect square trinomial here. And 0 plus 9 is 9. All right, so I'm going to rewrite this as x minus 3, right, times itself. So I can write that as x minus 3 squared equals 9. And now square root both sides. Remember, it's not equal to 0. It's only got to be equal to 0 in factored form. So these cancel out. X minus 3 equals a positive or a negative 3. Add 3, add 3. All right, so x equals positive 3 plus 3, and x equals positive 3 minus 3. Remember, I've got to get both positive and a negative 3 in there. This 3 stays the same. So 3 plus 3 is 6. Check. And here 3 minus 3 is 0. Check. All right. So again, you can't do all of them in every method. Some are lean a lot easier from one to the other, but a lot of them you can. And like for me, I would super choose factor method in this. I find it much easier, right? But there are others that I feel like complete the square would be easier. So that is part of your task, not only to solve, but to start figuring out what would be the best method. All right, you guys know what to do with questions, comments, and concerns. Really take ownership of your own learning. All right, I'm really proud of you guys. We have a test next week, so please make sure you're studying. Have a great and wonderful day.